For the first part of the class, I just handed out this worksheet, and we just filled in what we knew about the common Maclaurin series. For e to the x, if you remember, has this form: 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot dot dot. Okay, in sigma notation, that would be n equals 0 to infinity, and I'll write it this way for a reason: 1 over n factorial x to the n. Then we also looked at sine, which, if you recall, begins with only all the odd powers, x minus x cubed over 3 factorial, plus x to the 5th over 5 factorial, minus x to the 7th over 7 factorial, plus dot dot dot. Okay, so we know there's different pieces to this. One of the pieces for sure is alternating part, so we can accomplish that with negative 1 to the n. And then we just want odd, and how you can accomplish odd, think about how you accomplish even. Even would be 2n. So odd would be 2n plus 1 factorial, and then x to the 2n plus 1. Okay, similarly, cosine begins with only even powers, so you can figure out the sigma form for that. Okay, even powers, n equals 0 to infinity. The alternating part, even would just be 2n, so x to the 2n. Okay, what we're going to do next is we're going to derive the one for ln of 1 minus x. So our function will be ln of 1 minus x, and then we're just going to take subsequent derivatives. Remember, you're going to flip it. 1 over 1 minus x. Don't forget the chain rule because of that negative x times negative 1. So view this as negative 1 minus x to negative 1. We'll just take a few to get the pattern. The second derivative, I'm going to bring down the negative, so it's going to become a positive 1 minus x to the negative 2, but then again, don't forget there's a negative from the chain rule. Okay, third derivative, similarly bring down the 2, it's going to become a 2, 1 minus x to the negative 3, negative again because of the chain rule, and we'll just go one more derivative. Fourth derivative of x, bring it down, it's going to be 6, 1 minus x to the negative 4, and again a negative because of that negative x chain rule. Next thing I did for Taylor series is I plugged in 0. ln of 1 is 0. The first derivative becomes negative 1 at 0. The second derivative also negative 1 at 0. Third derivative is negative 2 at 0. And the fourth derivative at 0 will be negative 6. Okay, so those are some of the pieces, and we can keep going if we want. So the Taylor series went f of 0 plus f prime of 0 x plus f double prime of 0 over 2 factorial x squared plus f triple prime of 0 over 3 factorial x cubed plus so on and so forth. Fourth derivative over 4 factorial x to the fourth plus dot dot dot. Now if you simplify this, you're going to get a negative x minus, I'm going to actually simplify the fraction, 1/2 x squared, and this is a 2 over 6, so it's going to be a minus 1/3 x cubed, and you can see the pattern emerge. 4 factorial is 24, so if you reduce, it becomes minus 1/4 x to the fourth plus dot dot dot. Okay, so we're going to take this series and we're going to put it back in the worksheet we just had. So for ln, it starts out with negative x minus 1/2 x squared minus 1/3 x cubed minus 1/4 x to the fourth minus dot dot dot. Okay, in sigma form, there's just a big negative on the outside. I can start this sigma at 1. It doesn't alternate, so I don't need that. Everything is negative. And it looks like just 1 to the n, x to the n power. Okay. What we also filled in class, which I'll leave to you as an exercise, is 1 over 1 minus x and 1 over 1 plus x.